Hello. Welcome to this new episode of the CATIA TV. Today, I'm going to welcome Edouard Sutré, who is a creative design technical specialist in the R&D department in Dassault System in CATIA. And he's going to talk today about X generative design, its positioning, and the latest updates that has been developed from the latest release. So X generative design is a browser-based generative design technology, which is very important for CATIA. And there has been a lot of innovations lately inside the release, but also inside some different types of project. So one of the projects, Edouard is also going to present you, which is the work of Japanese designer, which is called Takumi Yamamoto, who has been at the origin of a project which is called the DB project, and which used X generative design as a technology for creating a car concept, which was inspired from the art and the music of the artist David Bowie. So I'm going to welcome Edouard, and he's going to present you the positioning of X generative design, the latest updates of the X generative design, and the work of Takumi Yamamoto. So I'm going to switch the screen, and I'm going to welcome Edouard. Hello, Edouard.
Hello, Cyril, and thanks for the invitation and for this opportunity to show you the latest improvements of CATIA generative design and also the project with Takumi Yamamoto.
Yeah, you're welcome. So thank you very much for accepting to be there today and to present us this very interesting work and these really interesting innovations. So what I'm gonna do is that I'm gonna let you kind of switch the screen and then start to present us the X generative design positioning and update presentation.
Okay, so I'm ready.
Okay, so let us go to the screen, and then Edouard, I will leave the floor to you.
Okay. So CATIA Generative Design is a new web application in the portfolio of CATIA applications. And you will see CATIA Generative Design, in fact, is to answer a new trend in the industry to create complex shapes. You can see organic shapes like on these pictures. It's a new trend. You will see it a lot in a new car and also new buildings, new products, everywhere, in fact. And the R&D team, in fact, developed this new web and cloud computation-based technology to answer this request of our designers, of our architects or engineers. And you can see here some, in fact, some designs or some products we want to be able to do with this new application, this new technology. So I will present rapidly CATIA Generative Design. The first thing to say is, in fact, CATIA Generative Design application is to create bio-inspired and complex shapes with stunning and generative patterns. You will see a lot of pattern shape you can do, in fact, with this application. Providing automated alternative study at early design stage. It means, in fact, this product is really to start new design projects, to try alternatives, to try new design variants, to experiment, in fact, with the generative approach in order to find the best design or the best style you want to use or to continue for your project. Here you can see also two pictures. In fact, I think the art of this application is to propose two different interfaces for our users. You will see on the left, in fact, it's possible to use the product the traditional way with interactive dialogues panels, and you click or you manipulate the geometry in 3D. But also you will see, because I will also do a quick demonstration, it's also possible, in fact, to open what we call the graph editor window here on the right, in order to continue your design or to develop your logic with an algorithmic way of thinking. I have a small and quick video, in fact, just to give you a first overview of the application. So here you see we are creating some geometries using the interactive interface, and then now we are using the graph editor to continue the design, to add some additional operators, and you retrieve, in fact, all the features you have used before. And finally, you can also play with some parameters in order to explore ideas or design variants. With a simplified view, you just see the main parameters. We will try to cover all these points during the live demonstration.
That's great. So you have, sorry, I'm kind of stepping into your presentation. So you plan also a live demonstration?
Yeah, I think it's the best way to show the application and to better understand how it works, I think.
Sure, that's great. And so what is interesting maybe to point out, I would say, is that you really have two user interface here. Parametric user interface and also graphical one.
Yeah. In fact, you will see you can use both at the same time in parallel. You do not have to choose the user interface you want to use. In fact, it's just use the best interface for the best use case.
Great. So it's at the same time you have the choice. Okay.
Exactly. And this is, in fact, the point I wanted to highlight. If we just want to give you the main highlights of this application in 4 points. The first thing to say about CATIA generative design is about the interactivity you will have and the 3D-centric approach. In fact, the product has been created to simplify the manipulation of 3D objects. You can see you will have 3D manipulators in order to predefine the size of some elements, the length of some shapes and things like this. This is really powerful, especially for designers to use, in fact, the 3D. The second point, in fact, you will be able to create simple but also really complex shapes and patterns with a lot of objects. This is the main point of CATIA generative design. You will deal with collection of objects. It means you will be able, in fact, to create a lot of faces, for example, in this example, and just with one parameter, you can jump into a really, really complex design, increasing the number of elements, for example.
Okay, so you really have the capacity to have to create really complex design here. That's really, really interesting. Yeah. Okay.
The third point, this application is fully integrated to the 3D experience platform ecosystem. It's not a standalone product. It's really integrated. You will benefit from the rest of the widgets. In fact, you will collaborate. You will store the data the same way as all our other solutions with, for example, the rich client. But here we are working in a web interface. It means nothing to install. And this is my last point. In fact, thanks to this web technology, you will be able to work anytime, anywhere, on any device. You can reopen the same data on another desktop or laptop or even a tablet. You will reload the model and you can continue your work. It's really nice, I think, for mobility also.
Yeah, sure.
And this new trend.
Okay. Yeah, so it can be really can work in ubiquitous mode, we could say.
Exactly. Yes.
All kind of devices, and it's really easy to access.
Exactly. So this is, I think, the 4 pillars of CATIA generative design. And the last thing to say for this introduction, I think, with this kind of application, we will target 3 main users. the creative designers at the beginning of projects in order to explore and create new complex shapes or patterns inspired by nature, for example, because it's a big trend, the bio-organic shapes and things like this. The same way, we will also address the architects. You see more and more buildings with really complex shapes and really stunning designs. And the last user, in fact, of course, our core users, we will also address the mechanical designers, the engineers, for example, in order to create rapidly new designs and adaptive designs, especially when you are trying to explore new structures of things or repetitive objects, like, for example, here, an escalator project could be really, really nice to use for this kind of use case.
Okay, so it's really an application which is really pervasive for all types of roles. Well, at least a lot of roles inside the design process.
Exactly.
Yeah, okay.
And about roles, you will see, in fact, this application is for the moment available in one role in the CATIA portfolio of products at Dassault Systems called 3D Pattern Shape Creator. So this role will give you access CATIA generative design application. This is the official name of the product to buy. And now we can jump into a short demonstration of the product.
Great.
So I will switch to my web browser here. So if you are not familiar with 3D Experience platform, in fact, you connect an ecosystem, a platform, and you will retrieve a dashboard. And in fact, you can create collaborative dashboards and invite people, but also you can create your own dashboard in order to work. And in this dashboard, you will have, in fact, different tabs or different widgets. You put some widgets. CATIA Generative Design is, in fact, one widget, and you drag and drop this widget to your tab. And you can expand it or not. For example, I can see I have the 3D space widget on the left side here, and I can, for example, just drag and drop models into my CATIA Generative Design widget, or I can simply start from scratch. So here, for this short demonstration, in fact, I will try to show you the basics on a really simple use case. The first thing, we will create a part, and here, in fact, I'm connecting the database. So we are working on the cloud, and all the data are stored in a secure environment. And this is the first step of the demo. Here, you retrieve this empty space ready for geometry creation. You retrieve on the left side what we call the specification tree, in fact, to have the list of all the operation you will create in your design. And I will start rapidly. For example, here you retrieve in the action bar all the geometry operators you can use to create 3D geometry. I will start by creating a grid of points, for example. Here you retrieve this kind of traditional dialog panel you can have in CAD systems, in fact, traditional CAD systems, and you have inputs to fill in order to complete the operation and produce a 3D result. You will see in CATIA Generative Design, we have the same layout for all the dialog panels. It's a generic layout, really easy, one input per row. And here in this area, you will select the strategy of the operator to create a grid. So, for example, you can create a simple rectangular grid or a triangular grid, etc. And you will see here, you retrieve, in fact, the strategy. Then you see with the color code, here, I just need to pick one input, a plane, to put my grid because of the orange color code. in green, it means everything is ready. You do not need to interact. It's just a parameter to play and to modify the result. So here I will just pick a plane, the first plane of my design. And you can see now I'm creating a grid of 3 points by 3 points. And I can increase now the dimension between 2 points and the number of points like this. Now you have this kind of simple grid. Okay. From this, for example, if you want, I can create directly a geometry. And something really different with CATIA generative design, I'm creating a sphere, but because I'm clicking, in fact, the result of my grid of points, I'm not creating a single sphere. I'm creating one sphere per point.
Oh, right. I see what you mean. So it's automatically instantiate the grid that you've created. Okay.
Yeah. And this will be really the key differentiator compared to our other traditional 3D modeling tools. Here, from the beginning, you will work with what we call collection of objects. It means when you reuse the output of a feature, it will automatically create the geometry on the different elements. So, and you have also a summary here of the number of spheres I'm creating here. So, in fact, 100 spheres because of my grade of points. Okay. It's just to show you the first things. Of course, you will retrieve contextual toolbars and things like this in order to rapidly access the geometry and start and trigger some commands. Here, I will delete the spheres. We will do something more complex, I think. This is, I think, a good first overview of the 3D immersive window and the capabilities behind. Then I will, in fact, I will open what we call the graph editor.
Okay.
So it's a secondary interface. You can re-layout, for example, your working session like this. And you retrieve the node, the grid of points here, but in a 2D view. And you also see the links between the elements. So in fact, it's just a different view of your design, and you can interact with this graph editor, but it will be really powerful, in fact, to create complex algorithms in order to create really generative designs to manage the links between the nodes and to understand, in fact, where are the errors and things like this. Because in fact, you will be the designer, the architect of your own logic here.
Okay.
CATIA generative design, you will create your in fact your own logic, and it's not just modeling. You are creating and capturing the design intent, and you can then, for example, copy it for a new design rapidly.
Okay, so you really are creating the building blocks of your design, which are connected each other in order to create the logic and your design, in fact. Okay.
And I will continue rapidly. For example, you can go back to the immersive window at any moment and continue. There is no boundary. In fact, you can continue like this. Here, I will translate, in fact, the points. So I will click the grid of points automatically, and I can use the 3D robot, the manipulator in 3D here, to move the points. But now I want to create a kind of random effect in order to do not move all the points with the same value. So for this, for example, here I can replace this value, the 40 millimeter value, by a random parameter. And you can also retrieve the box, the node here, the new random node is also available in the graph editor automatically. So you can, in fact, interact with the two interfaces at the same time. Here I will configure the random parameter. For example, the maximum length for my translate will be 30 millimeter like this. And the number of random nodes, for example, I will link the number of elements using the size operator here in the graph.
Okay.
You see at the output, in fact, the size operator will just give me the number of elements per row of my grid, and I will just, in fact, link the size output from my random number here in order to create this table of random values. And you see now the result, I have kind of a cloud of points, a lot of points. And so each point has a different value from the starting point. This is the cool way, in fact, to create a complex surface. Because you see, my goal now is to create a surface on top of the points. For this, I will just use the spline. And you see, I can, in fact, call the operator using this nice immersive menu. You just double click in the background and you type the operator you want. And here, in fact, I'm creating one spline passing through the 10 points of my grid.
So what is it? What is this spline exactly?
The spline, in fact, is just a line passing through the points, you see. So I have 10 splines. I will reduce a little bit, in fact, the maximum value of my random. So at any moment, you go back to your logic. And here, for example, the maximum, I will extract this parameter as a real node to play with it and to put, for example, 15 millimeters. And it will reduce the maximum effects of my translate. And here, just to try, you can put 0 millimeter and you retrieve your flat flat grid.
Okay, so you change the parameter and retrieve the flat lines. All right.
Exactly, and you have to put 15 millimeters to go back to this design. And the last step, in fact, I will use the outputs, the spline outputs, to create a loft. So in fact, the loft is the surface passing through the different sections. And here, the surface, in fact, is produced because I'm trying to use the different splines as the sections. And you can see, in fact, this kind of complex shape. You can do it in a few minutes, in fact, now. And this parameter is really, really nice and important for my design. So I will use this button to set this parameter as a controller. It's a controller of my design. And the random, also, the random effect, you see the new seed button here to redistribute the values, could be also interesting as a controller. So I will do it again, set as controller. And in fact, what is really super cool in this application, if you go back full screen like this, you can switch to the experiment view of your modeling. This is in fact just the list of the controllers of your design. So when you set a parameter as a controller, automatically it will add a row here, and I retrieve only the two main parameters of my design. And this is really super nice because, in fact, you can invite someone else playing with the controllers without having the knowledge of the graph behind.
Okay, all right.
Like for example, you can try to put back 5 millimeters, and automatically it will regenerate the design proposal here. You can press the new seed button in order to try a different distribution. And you do not have to go to the graph to do this. Just to end the demo, then I will just use an additional node like the triangulate one. It will create, in fact, a lot of triangles on top of the surface, like this. And then I will use the fill operator here. It's just to create a surface per triangle. And then I will hide the other box. And the size of the triangles will be really important. For example, if I put 20 millimeters, it will increase a lot the size of triangles. I will put this parameter again as a controller, and you will see now a third row here. I'm quite ready, I think, because my design is almost finished. And it was, in fact, just how it was to show you how to rapidly create something like really a deformed shape, and then trying to create triangles on top of it. could be really nice to start new patterns or new designs. And you increase the number of triangles, and you go back and you increase the maximum value of the random. And sorry, 15 too much. 15 millimeters is better to have this kind of nice shape, interesting shape to start a new project, for example.
Okay, so that's great. You can really modify a lot of parameters and create some complex shapes. It's in a very easy way. So yeah, thank you for the demonstration.
Yeah. So I will switch back to the to my presentation.
Sure.
Here, we have two PowerPoint. Sorry, this one. Okay, and I think now it's time to cover.
Yeah, we'll go to the project that has been developed by the designer Takumi Yamamoto. So yeah, that's great. That's great transition. Please go
Okay.
ahead. Thank you.
So yeah, in fact, last year we worked with Takumi Yamamoto on a special project. It was a great opportunity also for CATIA Generative Design in order to try this new technology in a industrial and a realistic, in fact, project. So I think I have a short video to introduce the project, but
Sure.
But just before, in fact, the idea of Takumi was to create a new concept car inspired by David Bowie and the music of David Bowie. And in fact, Takumi worked with two other colleagues to create this new design. And this model was 3D printed last year at scale 1. And I think it was possible to see this concept car during an event at Paris for the concept cars annual concept car event in Paris.
Yeah.
And I have this short video to have an overview of this project. So here you see Takumi sketching the preliminary sketches, and
this is Cyril Lanfly, I think.
Exactly.
Who participated to the project, right? Yeah.
Yes, Cyril, to work with Takumi in order to, in fact, to model the car. And here you see some pictures and videos of the fabrication.
Okay, so that was the yeah, and also Alexandre Larnac, I can read.
Yeah, worked on the visuals. Alexandre was really good for CGI stuff. Yeah. So this is in fact the project of the David Bowie concept car, and then in fact we had the opportunity last year after this project to continue a little bit the story with Takumi.
Okay.
Because during this project, something wasn't possible to do. Takumi wanted to generate on the front side of the car, in fact, a kind of pattern or texture driven by the music.
Okay. Yeah. Driven by the waves of the music.
Exactly.
Right? Yeah.
Yeah.
Okay.
Yeah. So like really to say, okay, you will generate the music by the music. In fact, it's so this idea was really interesting for us also to change CATIA generative design application and try to find a way to do this. So we started the collaboration, and Takumi shared with us some ideas, kind of a brief, some images to explain what he wanted to do. In fact, so you see this kind of 3D patterns or hexagonal shapes on top of the modeling. But it was just some pictures at this moment. And then we worked, in fact, with CATIA Generative Design to develop first algorithm, first design logic in order to create patterns, create different pattern variants or design variants on top of this surface here.
Okay. So if I understand well, what we see on the right, which is the wave of the music, has been transformed into the design pattern that we see in 3D on the left.
Yeah, so this is just an image. I have a video to show you some details.
Okay.
But this is, yes, exactly the story behind.
The idea. Okay, yeah.
The idea was to start by this picture of David Bowie's song, in fact, to try to convert it in 3D. So I will start the video, in fact, to cover this. So here, thanks to the image of the sound spectrum of this song, for example, we were able to convert it into the 3D world.
All right.
We have some operators to start from an image and to try to find the contour, and then with some additional operations, it was possible, in fact, to recreate in 3D a shape based on this image. And the idea was to, in fact, then take this sound, in fact, the 3D sound, and to intersect it with the model, the car model itself. And
okay, I see. So the points that you see here are the intersection between what has been recreated in 3D from the initial waves. Okay, I see.
Yeah, to have this kind of a line, the intersection line, in fact, and from this line, the idea was then to build a pattern driven by this line, in fact.
Okay.
Like a signature. This line will be also one design variant. You will see that just after. It was we called it the rift, in fact, to have the feeling that you intersect the model with the sound, in fact. So we'll continue. Here you see some additional operations. We are splitting the surface to generate some points. And thanks to different operators like the Voronoi one, we were able to create a kind of hexagonal pattern on top of the surface. Of course, what is really interesting here, we are not working on a simple surface. We are working in the context of the global concept car. We were able, in fact, to load the geometry. This geometry was done with iSemSurf, CATIA iSemSurf software. So really styling surfaces. And we were able to reuse and to start from the styling surfaces to develop this kind of pattern. Then the second step in this project was to play and to experiment, to explore, in fact, different patterns with Takumi. So it was a great opportunity. And like in my previous demo, we prepared an environment with only the main parameters. So in a simplified version, a simplified view of the design. And Takumi was invited, in fact. And Takumi was able to play, in fact, with the parameters in order to fine-tune the designs and to find, for example, the best combination of parameters to fulfill his ideas, for example.
Okay, I see. So it's still the place that was used for the I would say design inspired by the music, but then with generative design, he's been able to deep dive into the types of patterns that he wanted in this space.
Yeah, right? Exactly, and to change some parameters in order to fine tune, in fact, and to here we can see we have a kind of attractor in order to reduce, to have a kind of fading effect, to have something with a nice look, I think, for concept cars.
Okay.
So this was the second phase, in fact. this kind of exploration. And then at the end of the project, we selected 3 or 4 different variants or patterns. And thanks to another application called CATIA Product Perception Experience, we were able to create a kind of interactive presentation, 3D interactive presentation, to highlight the results of this project. So it's like, in fact, it's like a showcase. Here you see we are able to turn around the 3D model. So for the moment, there is no pattern on it, only some images to inspire and to tell the story. And then you can configure some viewpoints and play the different viewpoints automatically. And you can switch to different design variants or concepts with the 2D thumbnails here. So here this is the first result, the Rift one, just the intersection of the music and the surface. Then you can also click the 3D model to switch to another variant. This is the hexagonal one. And the size of the hexagons are driven by the music. Here it's now a pattern, a triangular one, but still the same. The triangles, the size is driven by the music. And this one is a mix. It's like, in fact, there is 2 different areas of big and small triangles. And it means, in fact, if you change the first and the initial picture of the sound, you change for a new song, for example, it will update everything. It will update the rift, it will update the triangles, it will update the hexagons. So in fact, you will regenerate a completely different pattern.
Okay, so it can be done automatically, that's what you're saying.
Yeah, you just have to change the image and everything will be regenerated.
The wave image from the song.
Exactly.
Okay, congratulations. It's very innovative and original.
Thank you. It was an exploration. It was to explore this, but the results were quite interesting, and especially also to, like I said, to try our technology last year at release. So this is a picture of the 3 guys, Takumi, Siri, and Alexandre, the authors of the David Bowie tribute concept car. And that's all for the
Takumi project. The DB project.
Yes, exactly. And to finish my my presentation, in fact, I have also a small video of other creations done with CATIA Generative Design. So I will just start it again, and you will see. In fact, it's to show you the different possibilities and all the new use cases you can reach with this application.
Yeah, so we can see that it's really possible to check a lot of different parameters and a lot of different shapes.
Yes.
It's
to
very,
explore.
very...
Here you can see on the rims, yes, or on the hood here, some patterns in automotive industry, for example, with nice pictures. And I think the possibilities are quite infinite. In fact, when you see the new products our customers are developing right now, it's amazing, I think. So this is a project done during a previous hackathon, in fact, with designers.
And this was the work that was done by Kengo Kuma, I think.
Yeah, exactly. I think that's all. This is the end of my video, and also the end of the presentation.
Well, that was great. Well, thank you so much for getting into so many details of the project of Takumi, presenting us the update of generative design. The positioning was a very complete presentation. So thank you very much. Maybe I have one or two questions for you,
Mhm.
if you would be okay. So
Okay.
what would be what's the future of the application? Is there anything that you would be able to talk about, or that you would like to highlight in the future works, or?
So this is at Dassault Systems is quite a new application, in fact,
Mm-hmm.
a young application. So for the moment, because also we are on the cloud, using the cloud infrastructure and everything, you will see there is a lot of updates over the year.
Mm-hmm.
So every 2 months there is an
Okay.
update.
Mm-hmm.
And for the moment, the development team is really working hard
Mm-hmm.
to deliver additional operators.
Mm-hmm.
So in order to do and to reach more and more use cases, and also trying to fine tune or to improve the user experience.
Okay.
So this is the two main pillars for the moment
Mm-hmm.
for the future of this application, and also because we have more and more customers, the idea is to listen their needs and their feedback in order to continue on this application. But yes, the two pillars for the moment, I think, is to add additional operators,
Mm-hmm.
missing operators, in order to create or to simplify some algorithms also, because
Okay.
with this building block approach, it's always possible, in fact, to find a kind of solution.
Mm-hmm.
But for some operations, maybe simpler or just one single operator could be really nice for our users. So we
Okay.
we are trying to do this.
Really
Uh,
improve the operators and the user experience.
yes, and
So that's really
for the month, for the next update, will come early July. You will have, for example, the possibility also to capture design variants.
mm-hmm.
Like, for example, when a design is quite interesting, you will store it. You will store, in fact, the values of the different parameters
Okay.
in order to try a new idea and then go
Mm-hmm.
back to this previous design. So you
Okay.
will capture, in fact, different designs with the experiment panel. So this is an additional capability of this application.
Okay.
Will be really nice um,
So
to in
that will
fact
be a good development for experimentations.
yes, exactly.
Yeah. Okay. All right. And maybe can ask you a question about the where on the Takumi project. So where is the car now? And is there still some investigation? When the car be found?
So I think you should ask Takumi directly.
Okay, I will ask him.
Yes, I think this project is quite finished now. The the collaboration with CATIA Generative Design, in fact, was to to continue or to finish, in fact, the story
Mhm.
and to let Takumi the possibility, in fact, to do what he wanted to do at the
Mhm.
beginning, create the kind of shape driven by the music.
Okay. Well, that's really an amazing project. So thank you very much, Edouard, for taking the time today to present us all these innovations on generative design and on the Takumi project. Okay.
Thank
So
you, Cyril.
thank you again, and talk to you soon.
Yeah.
Thank you.